Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time, I'm going to talk about the inverter modular air-cooled chiller. And this presentation is for EU market. This presentation divided into these three parts. Product introduction. First of all, I'd like to display how the air-cooled modular chiller evolution. The beginning is from 2000 years. The first is constant speed and scroll. And this is our first generation A series. And for the latest one, it will become this A series. Adopt the all DC inverter, means not only the compressor but also the fan. They are DC inverter. Inside the compressor, it changed to rotary, and also it is first to adopt the R32 refrigerant. And this is the first generation for the inverter. It's from 2019, and from 2020 it becomes this B series. Also, this information is the same, but this is still only R14A. Maybe you have a question that what is air-cooled modular chiller? And just like its name, air-cooled, that means in cooling we need to release heat to the air, and also in heating we need to absorb heat from the air, which is with the tube and fins heat exchange. And then modular, that means we can combine different outdoor units together or different heat pumps together to enlarge the capacity. The maximum we can modularize 32 compressors together. And the last is the chiller. That means just like this one, we can offer you the cool or the chill water or the warm water to heating up the system. And just like this, you can find it. This is the modular chiller. From here, we need to supply with the water pump, then absorb the water, and then after conditioning, which means in cooling, we need to cool it down. So we send this cool chill water to the fan coil unit for the room cooling, and then we go back to the water pump. And here is the product lineup for the heat pump inverter A series. Basically, there are two cases of it. We have the 35, which is this one, and a 60 and 65 kilowatt for this one. And this is both R14A and R32. And for the modularized, which means we can put different outdoor units together to enlarge the system capacity. The maximum for this one is go to this 1040 kilowatt. And here is the supply. Is this 3 phases, and inside we adopt the Gully cell-developed rotary compressor. And of course, later I will make a detailed introduction, and just pay attention to this certificate information. We have the Eurovan, CE, and also this PED. And we also offer you the FCU and AHU, and you can also purchase from our grid. And this is all the models we have. Application for this one, it is air cool, which means we don't apply the cooling tower to release heat, and it is very suitable or very popular in the where the water source is not enough, and also it is not that easy or not that convenient to install the cooling tower, or it is not enough room or not enough machine room for the chiller. Then you can consider this air cooled chiller. And on the other hand, for the heating, there's no need the boiler. And this is the detailed product lineup for the NAA, the R14A series. Actually, there are 3 cases of it. It's from 35 to 60, and the maximum is 65. And this 35, that means it is cooling capacity. For the nominal, it is a 32 kilowatt. And this NA means the inside refrigerant is R14A, and the last alphabet, that means the power supply, 3 phases. And I also put the cooling and heating performance here, and also the noise and the dimension, and also the compressor information, and also inside the refrigerant amount right here, just for your reference. This is for the R32. You can find that just compare with the previous one. This one here, we change to NH. That means inside is R32. The second chapter is product features. This is the operating range. For the outdoor ambient temperature for cooling is -15 to 52 degrees. And within this range, we can offer you the chill water from 5 to 20. And for heating, the outdoor ambient temperature is from -20 to 40 degrees. And within this range, we can offer you the hot water from 35 to 50 degrees. And just like what I have said, the inside compressor is inverter. We adopt it from our grid cell developer. It is rotary. And how it works is just like this. You can find it here is the router. When you just take a run, it will just compress. And also compare with the regular on-off, the efficiency is extremely high. And also this is very helpful or very high performance, especially in low load condition, because we can lower the compressor output to meet the load. And later I will display the performance test results. And here is the comparison between the on-off at the upper side and also the inverter. And for this inverter, that means we can change the compressor RPM to meet the rows. And here is an example. You can find that if we just require 70% of the rows, and then for this on-off, we just need to turn on and turn off by the time. It will be 70% on and 30% off. That is for that. And for the inverter, we can adjust the compressor RPM exactly to 70% to meet the row. And also the consequence is that from the compressor output, and actually this is the compressor RPM, and also you can find that this blue color, it is on off, and the orange color, it is the inverter. And also you can find that for the inverter, for the compressor, it is just on off and under inverter. And for this one, if we compare with the water temperature, you can find that the on off, the fluctuation of the water temperature is much higher, right? And also for the system output, which is how much power it consumes, also it will just like this. This slide displays how the compressor and fan operate, which is for the inverter, how we control it to meet the roles. And here is the performance comparison result between the on-off and also the inverter. And also you can find it for the cooling capacity. The blue line is the on-off, and also the orange line is the inverter. And also you can find that at 100% low, it is the same. And if the low is lower for the inverter, the efficiency, which is the EER, is also, it can be higher. The maximum is we can lower by max 36%. And not only the cooling, but also the SCOP for the heating performance, we can get 32% higher in general. So here it is a summary that for the SEER we can as high as 4.6, and for SCOP it can be up to 3.9. This slide displays how we can lower the noise of the heat pump. Generally, we have these 4 solutions, which is for the fans, we adopt the large plate, which we can offer more air volume. And this is the noise transmission with reduction sinking design. That means here is the fan motor, which will make the noise to be maximum. Then we just put the fan motor inside it, which is the sinking, and also at this area covered by the panels. And as for the compressor, also we just make these panels or the cover to block the noise. And on the other hand, on the control, we can also have the silent mode to lower the compressor RPM and also the out of fan RPM to lower the noise. So the maximum we can lower 5 dB, just for example for 60 kilowatt. Smart controller. This one is for the on-off, which is D and E series. The controller, it is press the button. And for the A and B series, the inverter, it is this one is touch screen. It's only 4.3 inch. Also very convenient. Heat exchanger. First is the dry tie cell and tube heat exchanger. This is for refrigerant to water, and also you can find that here inside is the refrigerant, and then it will cool down the water and also make it exchange with the water, and then flow out from here. It is the refrigerant flow inside the tubes. As for the water, just inside the shell out of the tube, get in from here and come out from here, and they just make heat exchange inside. And also you can find that for this one, the internal pressure loss is little, which can improve the heat exchange effect. And also we have this structure to ensure the refrigerant can divide it evenly into different tubes. And for this one, we have also considered the freezing protection, which means in cooling, as we need to cool down the water. If the refrigerant is very cold and makes the water lower than the freezing point, it may also make the system to be frozen, which may lead to the damage. And on the system, we have this countermeasure, these solutions For that, first is the water flow protection, which is located here. There is a water flow switch to detect if there is not enough water flow, it will trigger the error. And also we have the temperatures to detect if the water is too cold. We also have different solutions for that. And if in your local condition you find that it's very close, or you need to make the water temperature to be close to the freezing point, we recommend to add the antifreeze into the water. And also in winter, if you don't need to use this chiller for a long time, we still recommend to connect the water pump to the chiller, because we have the solution for the anti-flows. And of course, if you don't need to use for a long time, please release all the water to ensure there's no water inside the water system. Next is for the tail and fins. And first is for the fins, we adopt the slip fin. You can find that on the surface we have cut lots of the slips to higher the heat transfer efficiency. And as for the anti-corrosion level, actually in our grid design we divided the anti-corrosion level by the colors, which is the blue, golden, and black. And here is the fins. Inside it there are 3 layers. Actually these 3 layers for different level. The difference is just the thickness. And if the thickness is different, also the anti-corrosion level is different. And for this golden, it is standard. It can last 1,500 hours. Natural salt spray text. For the other components, firstly for the fan and the fan motor. And for the fan brake, just like what I introduced, we adopt the larger size design, which can higher the ventilation amount. As for the fan motor, for the A series 30 kW is IP24. For the 60 kW is IP56. And inside we apply this electronic expansion valve for the metering device. It can precisely control the refrigerant flow for different loads, and also it can provide the solutions for the protection, which is for the compressor high temperature. And for this modular chiller, in winter, which is in heating, we need to do the defrost if the outdoor ambient temperature is low. And if all the heat pump they adopt the defrost at the same time, then it will make the system to be cold, which is inside. It will make the temperature to fluctuate a lot, which means the customer will not be that happy. And for our modular chiller, we only allow 1/3 of the outdoor unit or the heat pump it can adopt the defrost, and after that it will just take turns for the defrost. For this one, we can ensure during the defrost period the temperature of the water will not drop too much or will not fluctuate that much. Next is for the modularization. Just like what I have said, we must support 32 compressors. And just pay attention that for this inverter and the on-off series, they are not completely the same, and also they cannot support modularize together, which means to control with the same controller, it is not okay. Equilibrium running time. That means for the compressor, you can find that in part low condition, which means we don't need all the heat pumps or all the compressor to turn on, and then based on the load, and the system will balance the operating type for different compressor. So in this example, you can find that the system only require half of the compressors to turn on, and then the system will make the balance first to operate, for example, this 4, and then after it achieves 440 and 20 hours for the accumulated time, then this 4 will stop. Then we will turn on this one. This is only 400 hours, and after it operates for another 20 hours, then this 4 will stop, and then we turn on this one. And the principle is just like this: first the compressor turn on, and it will first to turn off, and if it is first to turn off, then the next time it will first to turn on. Just balance the operating time to enlarge the lifespan. Not only for the compressor, but also for the water pump, we can also balance the operating time to enlarge or to prolong the lifespan of the water pump. Free master and slave modular. That means in a modular system, if you need to set the master outdoor unit, just change this switch is okay, and after that just connect this controller to it is okay. And also in this example, there are 3 heat pumps here, and the difference of these 3 is just the this switch on the PCB is different, and if this Y controller connect to the heat pump, this one we require this switch setting like this. And if you would like to change, for example, change this one to be the master, just like this. Change this switch, and also make this one to be different, and just make this controller to connect to it. And after that, don't forget to ensure the communication between different heat pumps is okay. Pedal flow switch. For this one, the purpose of it is just to detect the water flow rate to ensure the water flow rate is enough. And our latest one, we adopt the WFS22, the magnetic signal transfer, which is to replace this one. The purpose of it is just to avoid the condensing water accumulated here, and also to make it rust and corrosion inside, and finally this may lead to malfunction. We change it to this one. Simple and quick installation. And also in this example, this is the building, and this is the heat pump. For this one, there's no need cooling tower, and also no need the boiler for the heating, and also we don't require the machine room. You can install this one directly on the rooftop. It's okay. And also we support to install at the machine room or the service floor, and then you need to apply this air ducting to ensure the ventilation. And this one, the ESP of the heat pump max is only 30 pounds. Complete protection. From the design stage, we already consider all the protections, including for the compressor, which is this slide. First, we display the heating capacity in low temperature condition, which is just follow this one. This orange line is the inverter A series, and the blue line is the on-off. So you can find that as we can higher the compressor RPM, especially in low temperature heating. Then also for this one, for the on-off, the lower limit is only up to -15, because after that we cannot ensure it can operate. And for the inverter, we can make it as low as -12. And just compare at this part, we can higher the heating capacity by 17%. And this table displays the difference between the R14A, R32, and also R32 with PED certificate, the difference for EU market. Besides the refrigerant is different, the compressor also a little bit different. And this PED, we have a special certificate for this compressor, and also for the inside components, including the heat exchanger, gas liquid separator, and also there is a safe valve inside for the PED. And also for the R32 series, we have a liquid injection cool down solution, or the cycle for this. The last part is for the controller. Slide display how to do the external wiring, which is on the terminals. You need to control the e-heater or the water pump, or to display the operating state, or is there any error. It will also to connect the wire to here. And here is the requirements. For the modular system, you can connect the water pump or the e-heater or the running indicator to any chillers. And to control the water pump or the e-heater is only for the dry contactor or relay. And for the alert indicator or the operating indicator, they can make it together or separately. As for the external passive control, and which is just like this one, and on this case you can find that we install this chiller system, and also you can have this button to connect to this A and B, which is to then connect to the chillers. And also at the controller, don't forget to make it to be enabled. And for the detail wiring is to this 9 and 10. And also you should make it to be separated to different chillers. This slide displays how to do the modularize. And on this case, there are just two chillers. And we have the chiller number 1 and also chiller number 2. And here we have the dip switch setting. For modularize, we need to make it to be different. And also this is for the power supply. And inside there is a PCB. For modularize, we need to connect this CN25 to the first CN33, and then from this CN25 to connect to this controller. And also it is the same to the next chiller, which is to the next CN25. And this is the PCB, the dip switch located here, and the socket located here. This slide displays how to do the wiring from the chiller system to the PC. And on this case, you can find that this is actually our latest modular chiller. We have two compressors, so we have two PCB of it, and you can just do the wiring from the this CN27 to the left side, the PCB on the left CN33, and then from this CN25 to this one. And also from here, the output you can from this CN2. Then according to RS485 converter, we need to change it to the signal for the PC, which is for the BNS system. And here is the part code for this wire. As for this RS485 converter, according to the output, if you choose from our grid, we can provide you these two, which is this ME40 and GD02. This one is actually the same as the GMV debugger. You can also prepare from your local market. And actually here is already the standard RS485. What you need to do is just ask out your grid salesman for the protocol to do the communication. Is okay. If you would like to control different series, which is the on-off with the inverter by the PC or the BNS system, you need this CF612 to combine them together, which is actually from here the output is already RS485, so you just need to combine them together, and then also to allocate different address. Then if you combine them together and just output from here and combine this, in this case is 3 systems, then through this RS485 converter, then put to the PC. And on the other hand, for the communication, if the length, if it is more than 800 meters or more than 30 modules, which is 30 this CF612, you need to apply this RS485 repeater to ensure the communication. This slide displays how we check or how we monitor the operating data of the chillers. In China, every chiller we just equip with this GPRS or the 4G device to send the operating data to the base and then to our grid cloud. Then from our grid cloud, from the internet, with the PC or the smartphone, we can access to this one. Then we can get the operating data of different chillers, either for the modular chiller, screw chiller, or the centrifugal chiller. And for the overseas market, as we cannot send the data by the cell phone, so we need to connect this device directly to a local server, which is a local computer. Then we can access this computer by the internet, either by the PC or by the smartphone. And then also from here we can get the operating data of all these chillers. This is for the overseas market, and the detail you can consult from your grid salesman for detail.